going to be talking a lot about radicals, and so we're going to make a connection today in 8.6 day 1. Anytime you see a rational exponent, that means a fraction exponent. What that means is it's a radical, okay? So these are different parts of a radical. N right here, we call N the index, or indices is plural. X, the part underneath, we call that the radicand. And the actual symbol, we call that the radical. Okay, so we're going to look at a few examples here on how to kind of simplify some of these. So 16th to the 1/4 power is the same as the 4th root of 16. So this means what number times itself equals 16? What number times itself 4 times equals 16, okay? So how this works is you could break this down into pairs, or you could just kind of do this part in your head, but something times itself 4 times has to equal 16. So this is 2 because 2 times 2 times 2 times 2 equals 16. So the 4th root of 16 equals 2, okay? So radicals and rationals cancel each other out when they're the same. So the square root of 3 squared is just 3. The square root and squaring are inverses, they're going to cancel. You could also treat this as the square root of 3 squared is the same as this. So rules with my exponents, I multiply, and that ends up just being 3 to the 2 over 2, which is 3 to the first, which is 3. Okay, so all the same thing. Same thing with cube root. 3 and 3 cancel, and I'm left with just 4. 5th root and 5th power, I'm left with just 7. Okay, here, when it's multiplication, we can actually break this into 2 separate radical expressions. So this is cube root of 3 to the 3rd times cube root of 4 to the 3rd. So in doing that, now the cube root and cube will cancel. Same here. So we're left with 3 times 4, which is 12. Okay. We have the same thing going on here. So I can break this into the cube root of 2 cubed times the cube root of, now I would like something to the 3rd power. So I can also do this, right? Because if I multiply 2 times 3, that equals 6. So why would I do that? Well, now the cube root and cube cancel, and here cube root and cube cancel, I'm left with 3 squared, okay? So 2 times 9 then gives us 18. So I want to rewrite all of these so that there's something to the 5th power, okay? So this one is 2 to the 5th. This one I could rewrite as 3 squared to the 5th. X to the 5th is fine. Y, I could do y cubed to the 5th, again, because it's got to multiply to be 15. So then now all those 5th roots are going to cancel, and we're going to be left with 2 times 3 squared times x to the x, 5th root and 5 will cancel, times y cubed. Okay, if we put all that together, I get 2 times 9 is 18, xy cubed. Okay. So this guy, 5th root, that's a pretty big number, but actually in the next video, we're going to encourage you guys to memorize like 1 through 5 to the 5th power. So 1024 is actually the same as the 5th root of 4 to the 5th. So then I can cancel those out, and I'm left with just 4. Actually supposed to be 5832, okay? And I'm just going to show you kind of a cool trick. You might have recognized this from Algebra 1 or geometry, but we can create factor trees with our roots. If it's an even number, we can divide by 2. So I can do 5832 divided by 2. 2916. That's also even, so I can divide by 2 again. Oh, sorry, I'm going to keep it going like this. I'm going to keep 2 on this side too. $729 will not divide by 2, but it might divide by 3. And this might divide by 3. Yep. 3 and 81. And then I know 81 I could divide into 9 and 9. I actually don't need to keep going. Sorry. So all I did was create a factor tree, numbers that multiply to be this. I could break 9 down into 3 and 3 as well, which I'm actually going to go ahead and do that. And we don't want to break it down any to the point where I'm going to use 1. So if I'm looking for the cube root, I need 3 of those numbers multiplied. So this is the same as 2 cubed, right? This is the same as 3 cubed and another 3 cubed. So here's really what I have. I have cube root of 2 cubed times 3 cubed times 3 cubed. So based on what I saw from that previous page, all those cube roots are canceling and we're left with 2 times 3 times 3. So 6 times 3 is 18. Okay, so you guys, I will show you how to do the cube root on your calculator, but this unit and this quiz is going to be primarily no calculator. Okay, so there's going to be some things that we're going to ask you to do without a calculator option. This problem like this will be maybe on your homework, but nothing that big will be on your test. But it's just kind of important to understand how those factors can be simplified, okay? So on your calculator, if you ever need to do the cube root, it's under math. So math, and then if you scroll down right there, that is the cube root. So then I could do the cube root of 5832 and get 18. Okay, so this would be for numbers where you can't have the ability to use a calculator. If you need to do the 4th root of something, I would do 4 and then math, and this guy where it has the x in the index, then I could do the 4th root of whatever. So if I want the 4th root of 16, that'll give me 2. Okay, so there are how you can do roots on your calculator, but most of this unit is going to be no calculator. Okay, something to know about rational exponents is we can write this a couple ways. The denominator is the radical. The numerator is a power, okay? So this is a power, this is the radical. Okay, so what that looks like then is I could do square root of 4 cubed, or I could do square root of 4 cubed. These are the same thing, okay? These are equal. So I would probably prefer to do this just because it's smaller, okay? So square root of 4 is 2, and then 2 cubed is 2 times 2 times 2, which is 8. We'll get the same thing this way. So 4 cubed is 64. Square root of 64 is 8. So we get 8 no matter what. That's just kind of 2 different ways to look at it. So we're going to do it just in ways that make sense to us, okay? So this one, I know the cube root of 8, so I'm going to do it as cube root of 8 and then to the 4th, okay? But again, you could do it as cube root of 8 to the 4th. I don't like to do this one again because that number is going to be really big and I'm not going to be able to do that without a calculator easily. So I'm going to do this route. So 2 to the 4th means 2 times 2 times 2 times 2, which is 16. Okay, this one, same thing. I usually choose to do the root first. So I'm doing square root of 36 and then raised to the 3rd power. Okay, so square root of 36 is 6. 6 to the 3rd power is 216. Okay, cube root of 64 and then squared. Cube root of 64 is 4. 4 squared is 16. Okay? All right. Now, there is an important thing with exponents when we have no parentheses. This is the same as -1 times 8 to the 1/3. So this is the same as -1 times the cube root of 8. So -1 times 2, which is -2. Okay, this is asking us to take the cube root of -8. Now, I can take odd roots of negative numbers. So if I think -2 times -2, right, is 4, times -2 is -8. So the cube root of -8 is -2. So these end up being the same when it's an odd root, okay? Even is going to be a little bit different. So this is still means -1 times the 4th root of 16. 4th root of 16 is 2, so I get -2. When it's in parentheses, it means what is the 4th root of -16? Now, there are no real answers here because if I do -2 times -2 times -2 times -2, I get positive 16, not -16. So this has no real answers. Okay, so just to kind of summarize that piece a little bit, you guys, here is, okay, the roots that we get. So odd index is that number in front of the radical, right? The kind of that little one. So if it's odd, we're always going to get one real root. If it's an even index and positive, there's actually 2 real roots. And if it's an even index with a negative radicand, there's no real roots. That's the one we just saw. And if the 0 is radicand, then there's just 1 root of 0. Okay, so let's do this, you guys. So this guy, we can treat this as, yeah, let's do this. So this is the same here as 32, the 5th root to the -3rd power, okay? I can either put the negative on the 3 or the 5, it doesn't matter. It's a little easier to think about here. So the 5th root of 32 is 2. So now we're asking ourselves, what is 2 to the -3rd? Well, remember, this is 1 over 2 to the positive 3rd, which is 8. So 1/8 is this guy. All right, guys, that is the last example for this video. Thanks for watching. Actually supposed to be